Hey there! So a quick video to kind of explain to you what you're about to see. In this case, this is what we call a mini course. As you probably know by now, us at TEJordan, we do a lot of online trainings. What that means is that if you were to go on our website, tejordan.org in this case, you will see that we offer various trainings from Excel, SQL, advanced spreadsheet visualization, also on advertising with programmatic advertising, programmatic media trading, etc, etc. And in attempt to make people discover our courses, we decided to kind of bundle up some part of our courses into what we call a mini course. This 30 minutes to 1 hour course is completely free, of course, and just aims to kind of show you what we do as courses. And afterwards, if you are interested in checking more of what we do in terms of courses, you can just go into the description of this video and click on the link to just find all of the courses we do, and who knows, maybe continue on this learning journey with us. So enjoy the video, and please also just let us know if you have any feedback, any remarks, any things you want to see us improve. This is how we can improve our videos further and our learnings. Thanks a lot for watching, and talk to you soon. Firstly, let's calculate the total scores for each specific subject. To do so, we use the sum function, which, as its name suggests, takes different cells as parameters to sum up their values. So we start by initiating a function with the equal sign. We then write sum followed by tab to validate the desired function. Notice that there's a small L box indicating the different parts of a formula. In this case, we can see that the function takes as many cells as we want to sum up the values. We could select the values one by one with our mouse, but let's rather use the shortcut learned so far. Let's go to cell G2, select the cell, and with Command Shift plus down arrow key, go to the last row. As you can see, using these shortcuts can really come in handy. Once we have the sum of the first score validated with enter, we can simply apply the same formula to the other scores. If we look at the sums, we can already see that students typically score higher in reading and lower in math. Let's confirm that by calculating the average both manually and with function for the example. For the manual process, we'll need a count, as the average of something is just its sum divided by its count. We already know that there are 1000 students in the dataset, but still let's confirm this using the count function. The count function works just like the sum function, as it takes multiple cells, either divided by a comma or by a colon. You can however also calculate the average by using a function, simply starting with an equal sign to initiate the function and then typing in average function. Interestingly enough, you can see that the two average results are formatted differently. This enables you to see that Excel stores the value but only displays the formatting that you want. If we want, we can set that average to be an integer number. We can also ask to have 3 or even 10 floating points after the comma if desired. There are different logical statements which act differently according to your needs. The first logical statement is the AND statement. AND will return true if all of its components are true. If we now quickly go back to a student performance worksheet, we can write a statement that only returns true if and only if the students get at least 80% in both subjects. Once we validate the formula and apply it to all of the rows, we can see that all of the outputs are either true or false. Let's go over the OR statement. The OR statements return true as long as at least one condition is met. This time, a student now needs to have obtained a grade of at least 90% in any of the subjects. In this case, we can simply use the OR statement and set each score as being strictly higher than 90. If just one of the scores proved to be higher than 90%, the OR statement will return true. Notice that there's no difference in the result between someone who got 90 on all of the 3 subjects to someone who got 90 on one but failed the other 2. In this example, we only want to keep the entries where only one exam was failed. For this, we can use the binary property of true and false to calculate the sum of courses with a grade lower than 50. Remember that true and false can also be written as 1 and 0 respectively. In our case, there are 3 conditions to check, so the sum of these 3 conditions would always be between 0 for someone passing all of the tests and 3 for someone that failed them all. What that means is that the value of 1 is what we're looking for, as that means the student needs to retake one exam. To apply this, we'll create a function which translates to If a student only failed one exam, the output is retake, otherwise he either passed or failed. The first step is to write if, then use a bracket to confirm the function, following by the sum function. Right after that, we go on to write a condition for each of the exam being lower than 50. We then put an equal sign after that sum function and set that value to 1. We set that value to 1 as we only want one exam to be failed in that case. If the sum of the courses failed is thus 1, the function will go on to the value if true, otherwise it will go on to the value if false. The second part of this function is the value if true. In our case, let's put the string retake. And don't forget that we need to put text in quotation mark to make sure Excel understands it as a string. Finally, for the value if false, we use the same principle, but with pass or fail. Now that we've done the first part, we still need to check whether the student passed or failed. We can simply do so by adding another if statement within the value if false part of the function. Previously, we created a function which assesses the student who needs to retake an exam. We'll now change the value if false part of that function with another if statement to complete this task. For this condition, we can simply use the sum function used previously, except that this time we use an OR statement instead of a sum. As we've previously excluded all the students who need to retake exam, we know that any students that failed exams left in the selection have failed at least 2. This is why we can use an OR statement. Let's say that in my student performance worksheet I want to count the number of students who completed the preparation course. I can just start with an equal sign to initiate the formula, then write COUNTIF, an opening bracket, then choose the range, which is column F in this case, a comma, then go to the second parameters and write between quotation marks completed. And the job is done. Just note that by default, COUNTIF takes the equal sign. In case you want other conditions, like checking the grades greater than 80, you can just write the greater than sign followed by 80, both in quotation marks. Easy enough, right? First, let's understand the essence of a chart in Excel. There are numerous types of charts: bar charts, pie charts, line charts, and many more. Each type is suited to specific kinds of data and analysis. Despite this variety, we can broadly classify charts into two main categories: proportion graph and axis graphs. Proportion graphs are all about comparison. They show how a particular category of data stacks up against others. These graphs don't rely on axes, but instead represent data categories with different sizes or proportions. A classic example is the pie chart. Imagine a pie cut into slices where each slice represents a different data category. The size of each slice changes based on the proportion of the total. In contrast, axis graphs use one or more axes to plot data. These charts are ideal for showing changes over time or comparing different data points along common scale. The bar chart is a classic example. It typically has two axes, let's say one for the count of something and another one for different categories. The bar chart excels in showing how different categories compares in terms of quality or frequency. Now onto chart formatting. Excel offers a plethora of formatting options, ranging from preset styles to detailed customizations. First, we'll create a histogram to analyze the distribution of student grades. This example will demonstrate how to transform raw data into a meaningful chart. Step 1 is preparing the data. Start with our student performance worksheet. Assume we have a list of student grades. Calculate the average grades for each student. We then insert a new column titled average grade and use the average function to compute the averages from the existing grades column. Step 2 is creating the histogram. Select the data in the average grade column. Then go to Insert tab to click on Insert Statistic Charts and choose Histogram. Excel will automatically generate a histogram, but it might need some tweaking. Step 3 is formatting the histogram. We start by adjusting the numbers of bins to change how the data is grouped. Right-click on the bins, select Format Axis and modify bin width or number of bins to better represent your data distribution. We then customize the colors of the bars for clarity. We click on the bars, choose Format Data Series and select your preferred color. We can also add a title and axis labels for context. Click on the chart and use Chart Elements buttons, the plus icon, to add and edit titles. Now let's use a pie chart to compare the number of students who completed the preparation course versus those who didn't. The step 1 is to organize the data once again. In the same worksheet, assume we have a column indicating whether each student completed the prep course or not. We then calculate the count of students who completed the course and those who didn't. For this, we'll use the COUNTIF function. Then we can create the pie chart. To do so, we'll start by selecting the data with the completion or non-completion of the course preparation. We then navigate to Insert, Pie, and select Simple Pie Chart. The next step is to customize the pie chart. Once the chart is inserted, adjust the colors of the slices for differentiation. You can then add data labels to show percentages and counts within the pie slices. Click on the chart, then on Chart Elements and check Data Labels. And then choose a format that shows both percentages and absolute numbers. Then you can update the chart title to accurately reflect what the chart represents, like completion of preparation course. First on our list are tick boxes. These handy boxes work differently on Google Sheets or Excel, but in short, they enable dynamic buttons and entries for users. To create a tick box, just go to Insert, then select Tick Box. From this point on, 90% of the job is already done. If you now reference the tick box with another cell, you can see that by default it will show as false, and once you tick it, it will show as true. Coming back to our advanced marketing dashboard, you can see this is a technique I've used to select the dimensions to show in the dashboard. I can use the cell reference, usually after renaming them, in different functions to use in my dashboard. Easy enough, right? Now that we've explained tick boxes, let's go over drop-down list quickly. They follow the same principle, avoiding manual inputs and thus errors. Similarly as for tick boxes, just press on Insert, then click on Drop-down. This time you can see a handy menu appearing on the right side. This very cool menu enables you to choose the type of drop-down, which can be from a range or text values. Once you have selected the type, you can also decide the range of cells on which to apply those lists. Then you can choose the options, add or remove them easily, change the ordering, and also add colors to them. I quite like drop-down on Google Sheet, as this enables easy visual categorization of the inputs. On our future campaign checklist dashboard, you will see these colors enable us to choose a platform, each platform having its own colors. This is a visual way to easily mentally classify the data, so it's very easy to use. Similarly as for tick boxes, the value of the cell will change based on the drop-down value selected, making it easy to create rules and conditions based on them. In this segment of our course, let's delve into an Excel feature that is often overlooked but incredibly powerful: data validation. To streamline data entry and minimize errors, we set up drop-down lists. This way we avoid typing errors and ensure consistency across our datasets. But before we dive into it, a quick tip here. Be mindful of how you format your list items. If you include spaces, Excel will incorporate these into the values, which could later affect your calculations or conditional formatting. For the VAT, meaning value added taxes rates, we face a slightly different challenge. VAT rates can vary, so we need a bit of flexibility. We set up a drop-down list with the usual rates 0, 6 and 21%. However, since VAT rates might differ, we opt for a warning notification instead of a strict stop. We add another layer of validation in a hidden column, ensuring that any VAT rate entered falls within a reasonable range, say between 0 and 100%, represented as 0 to 1 in decimal form. The final step in our invoice cleanup is to ensure our calculation for net amounts are correct. We add a formula that will automatically calculate the net amount based on the total and the VAT rate. This way, we remove the risk of manual calculations errors. With these data validation rules in place, our spreadsheet is not only more accurate, but also more user-friendly. It guides the user through the correct inputs and reduces the likelihood of errors, making the entire process smoother. This example underscores how essential data validation is, especially in scenarios where data accuracy is paramount. Another very handy feature of both Google Sheet and Excel when personalizing dashboards are themes. These are often overlooked, despite saving a lot of time. Let's come back to our dashboard. If I want to easily change all the graph colors, I can just click on Format, then select Theme. You can see that in that case, the colors are the ones from Ted Jordan. I can just modify them to the new colors I want, change the font and press on done, and voila. Of course, in that case it's a bit more complex than that, as a lot of the cells are colored, but for that I used some conditional formatting. This is once again to be able to easily modify them, so I can just go and modify the formatting rules of these ranges, change a few things manually, and the job is done. On Excel, the principle is pretty much the same, except that I typically use already created teams. I can select an already existing team in the page layout tab, like Berlin for Ted Jordan, then go to colors, find the best match for me, maybe even change the font, and once again the job is done. For one of the last theory points we'll cover, let's see how we can create custom charts just with a little tweaking of regular graphs. First on our list, let's create a gauge chart. If you look in the chart offered by Excel or Google Sheets, you can see that the option to create such a chart is not available. So how do we do it? The first thing we will need are the data about the completion. For this we need 3 data points. The first is the completed part of our chart. In an example where we want to track the progress of something, this will be the percentage of the task being completed. You can either set that up in percentage over the total amount of tasks, or as the number of tasks performed as is. For percentage, just divide the number of tasks completed by the total number of tasks to do. Second, we need what's left to be completed, either by subtracting the full amount by the first number, or simply counting the number of tasks to be completed next. The process is the same for percentage, except that this time it will be the uncompleted amount divided by the total. Lastly, we need the total number of tasks, or 100% if you've opted for the percentage rule. Now that we have this, let's just add a donut chart. Then I will change its angle to 270 degrees to make it so that the total represents the lower half of the graph. I can also adjust the size and maybe add a 1% explosion to better distinguish the different parts. Lastly, let's format the graph. I will adjust the format of the 2 upper parts and fill the one below in white. Lastly, we can just add a shape text box, format it to be the completed part, and change its font color. Now we have a working gauge chart that changes automatically based on the completed task. If you have a process with a lot of steps, conditions of whether or not a step must be completed, and missing a step can cost the company a lot, this is the spreadsheet for you. But before going into the conception of this file, let's first see what it does and how it does it. As such, the team will start by creating a copy of that dashboard to avoid all working on the same file, renaming the file with the campaign name, then filling the necessary details for the dashboard. The first information is the DSP, which are platforms we use to trade campaigns in my side of advertising. Every platform will have its own requirements and step to do, so it's an important input. Next, they mention the format they use. Typically, large campaigns more prone to errors have multiple formats in them, but just know that each format has its own requirement as well. Then there are the pixels required inputs. Pixels in digital advertising are snippets of code, which enables to follow the conversions, or rather the actions performed by the user. If a client wants us to optimize on the sales generated with the campaign, we'll use pixels. Next step is deals. In my line of work, you can either deliver campaigns by yourself, finding the inventory you need, or you can contact publishers to bundle interesting inventory for you in a deal. These deals, as you might expect, require different steps than doing everything by yourself. Lastly, we have the creative type, or more simply the type of file of the visual assets. If the assets are simply images in PhD, it's easy. But if, for instance, they are set up in HTML5 to add some animations into them, there are different steps to setting them up on the platforms. With all of that referenced, the checklist becomes the next step for the setup. First, I will list all possible inputs I will need. For the platforms we mainly use, here is a list: TTD, DV360, Xander, Yahoo DSP, and Oak. Let's use data validation and assign each platform with its own color to make the dashboard easier to use. The color used are directly linked to the company logo colors to make it easier to associate with the user. TTD logo is blue, for example, while DV360 is green. Next, we have the format, for which we count 6 at the moment: display, native, video, CTV, DOH, and audio, but only created 5 data validation fields in this case. Each platform is indeed best suited for certain formats, so it would make very little sense to put all the formats on one platform under one campaign. The reason why I did not create colors for these is that I don't want the file to look like a mandala and stay a bit professional. The following inputs are whether or not a pixel is needed and if we need to use deals. Each will get a tick box, as this is a yes or no question. And lastly, we have the creative type, which can be platform hosted, meaning we just upload a file, other hosted, meaning we just use a URL for the DSP to access the server on which the file is, and HTML5, which is a bit different than just simple upload, as there are a few things to double check, as everything is supposed to be hard-coded in the visual, including what happens when you click, the animations, etc. And with all of that, step 1 is completed and we have our input boxes. On to step 2, which is the longest, but we have simplified it for you to not take 2 hours of your time showing you this. On the first step, we have all of the steps which are default, meaning they will always be on, which we color in blue. On the other hand, we have steps in yellow, which are just a few examples of steps which depends on the condition. Let's cover a few examples so you understand the principle there. The first condition is pixel setup. For this, we'll need to ask the client to set up a pixel if there is a need for one. So the condition is that if the pixel required input is ticked on, so if cell B2 is true, print true, otherwise false. The next one for events receiving fires has the same condition, as once the pixel is set up, we need to check if it fires correctly and thus if we receive information from it. Then let's cover a more complex condition with the viewability. Viewability is a metric available for display, video and CTV formats, which shows the percentage of impressions, meaning ad delivered, which actually gets seen by users. As such, we need a condition that checks in all of the 5 data validation fields for formats if one of these 3 formats are present. As we only need one of the 3 formats present in any of the 5 fields, we'll use an OR statement, which will output true if any of the output field has any of the format required. So the function goes as follows. If any, meaning OR, of the cells, meaning B3, C3, D3, E3 or F3, as any of the 3 formats, it will output true, otherwise false. So in short, we have a large OR statements that checks if any of the 5 input fields validates the condition. And for each input field, we have an OR statement showing if the value is either display, video, or CTV. Also, I have not mentioned it prior, but the filter function will follow the order of the listed items. So if, for example, you need the advertisers category first, put all of the steps of this category first in your task sheets. Last for step 3 is to add the tick boxes and expand them to the maximum number of conditions, then add a conditional formatting rule that says that if the B value is blank, change the font to white to hide that tick boxes. Also, to set up the function of the conditional formatting, you just create a function for the first cell/row and it will automatically apply to the rest. That means that the first instance in this case is C9. So we'll create the isBlank function with B9 and the function will understand to automatically adjust the cell for each. So for C10, it will take on the value of B10. If you ever need to use conditional formatting based on one cell though, just use absolute referencing using the $signs as you have learned throughout the course. On to step 4 now. Let's create our tables for our 2 graphs. For the number of tasks left, I will use 2 functions. First, the number of tasks uses COUNTIF with the wildcard symbol. When I use that wildcard symbol, I just tell the if function that if there's any character, whether it is a number, a letter, or a symbol, I'll ask the if function to count the cell in. A warning though is any symbol also means that a space would be counted as a symbol. Second, we have another COUNTIF, but this time counting the ticked on boxes in column C. So the function is very simple. COUNTIF C9 to C54, true. For the completion in percentage, we use the same 2 functions except that this time we'll divide the second one, meaning the function counting the number of tasks done, by the total number of tasks, then format the cell in percentage. But for the first graph, if you remember correctly, we had 2 bars in the chart. The percentage completed, which we just calculated, and the incompleted task. For this, let's just go to cell J3 and do 1, meaning 100%, minus the completion value. We can then hide or show the value depending on your preferences. And we are now ready for graph 1. Let's go on to create graph 2. For graph 2, the principle is the same, except that this time we want numbers instead of percentages, and we want these metrics for each category. So let's start by listing all of the categories, then use COUNTIFs with S in the end to only count the instances where the A column value is equal to advertiser name, meaning N2, and that the tick box is equal to true. I will also use absolute referencing for A and C columns to be able to autofill that function easily to the other categories. Let's finish with the final step. Let's create these graphs and format them. First, the completion graph. I will add a graph into Insert, Graph. click on the three dots and edit the chart. First, let's select the data range, so cells I and J3. We can see the colors are not correct though. To solve that, we could go to Customize, Series, then change the colors of each bar manually, or just change the theme colors, so that's done automatically. To change the theme color, let's go to Format, Theme, choose the color profile and customize it. The accent 1 is going to be the color of the completed bar and the accent 2 of the uncompleted one. So let's just make accent 1 darker and accent 2 quite light in color. I can also adjust the background color if need be, then go back to formatting my graph. But note that playing with the theme will also change the entire color palette, so you will have to redo conditional formatting for each category. Formatting now. First, you know me by now, I don't like grid lines, so let's remove them in grid lines and ticks. Select horizontal axis and untick major grid lines, and vertical to untick major ticks. Let's go back to series and select apply to all series to add data labels and format them. I would advise auto for the background to have lighter background with black font and darker ones with white font. I can then go on with the formatting by removing the chart border in chart style, adding a title and formatting it, and changing anything else we want. For the second graph, let's follow the same steps, except that this time we'll take as data source the second table values, so N2 to P6, and to finish, let's format it, removing the grid lines, change the totals, and we are done.